Awesome. I want you to feel free to turn on your videos and or play with any backgrounds. This is, I don't know about Ivan, which is our real speaker, but this is I'm Not a Cat. So just to be aware of that.
That's an embarrassing looking video.
Why is that? Why would that be embarrassing? I'm not a cat.
Uh, a sad cat talking. Reminds me of
Yes.
this one video showing how a lawyer
Mm-hmm.
is talking to a judge with animated cat in the background.
Right. Yes. Oh, you saw that. That was the I believe it was Robin Hood Congress talking. That was a very important cat, actually.
That was pretty funny, especially the fact that he wanted to keep going as a cat for the rest of it.
Indeed, he had no problems with that. So that's fine. You guys sometimes feel imposter syndrome. I feel that somehow. It just seems to loom over me. You know. By the way, is that the right way up? It isn't. It's backwards for me.
That looks right.
Okay. Thank you very much.
It's right way.
Thank you. So I think you guys should all feel like we're all part of this group. We're all part of, you know, part of a. I wish you guys could all be here in the bowling alley with me to figure out what, but we're not. So we'll do this virtually. I literally just finished a meeting with the sort of other organizers. We have a sort of a South Florida sort of organizer meetings where we share information with each other. We let everybody else know what we're doing, what's working for us, what's not working for others. So that's something that we just get out of. And one of the things that I truly honored and very glad was that you could all join me. There are so many of you. There are 64 of you that are signed up, and I'm sure some of you left already because of the fact that I wasn't letting everybody in. But thank you for that. The people that have joined us and have been able to come see exactly what's going on. So let me quit this. Leave this meeting, so that should be still going on. Okay, pardon me, I'm just running around and making sure all the different channels for Mr. Ivan are working. Still going on. Oh my, sorry about that. Little feedback. So my name is Damien Montero. I'm one of the three organizers of Boca.js. Some of the other organizers might not be here just yet, but let me keep on. I keep on forgetting to admit people. So we meet twice a month. We used to meet once a month. We now meet twice a month because we are now the combination, of course, of Boca.js and South Boca.js, Palm Beach JS, and React Broward. We now joined forces to become FloridaJS and to sort of illustrate what an amazing group. We invited Ivan to come join us and give him his amazing workshop. Feel free to come to floridajs.com. I promise you next time I will take care of these situations where you guys have to be admitted to be in. You guys next time will be able to be joined instantly. I'll work on why that was this situation. But thank you so much for joining us. What do you have? 1, 2, 3, 4, 5, 6. My goodness, 24, 30 people already on. Ivan, why don't we give him a couple more minutes? We are just 5 minutes past the normal hour. So if anybody wants to have any questions or any suggestions of other presentations, we do have, let me see if we've announced it yet, we do have 2 presentations after this one coming up. Not to diminish the amazing work of Ivan, but just to remind you, the other events, I don't know if we've put them up yet. We're going to be talking with a particular major speaker on GitHub Actions. That major speaker hasn't given us their logo and information, so we're working on that. And we'll have someone that I think you will recognize on March 30th, which was the person who was involved in jQuery and Microsoft Edge. Believe it or not, they actually moved from jQuery to Microsoft Edge. That will be coming up. So as you can see, the lineup here is tremendous. Thank you everybody for the event that we had. Over 120 of you join us in another event where we talked about one of the creators of React.js. We will have as many of those top billing people as we can, as I keep on clicking on admin. Ivan, people don't stop. They don't seem to stop coming to you and all that. So I will continue clicking on admin even if we start afterwards. We want to thank Ivan for this event. We do have 2 giveaways at the end of the presentation. The first giveaway will be a free license for a year and essentially for life for JetBrains, so Webpack or not Webpack, WebStorm, PHP Storm, Refactor if you're a C# fan. We will also have a full, let me get the full information about it, a full subscription for a month to a Vue course where you can get up to date with Vue. I know that's a big fan of, we have Vue and Jeremy. That will be from Vue Mastery. We'll give that as well to different ones. So come make sure to join us at the very end of the presentation. This is FloridaJS, but more importantly than anything, Ivan, are you ready to make us learn all about AWS with your AWS workshop? No,
Yes.
I see. Oh, I see that. I like
Yes.
that. I like that. Now, I saw that, by the way, I saw that we have a picture in the event. Were we going to be using the picture, or are you going to be showing it to us a little bit later?
Oh no, I just I have a presentation to kind of talk about the layout, and then we're going to do kind of like a demo and dive into the code to kind of show you a little bit of how things wire up.
Perfect.
But everything is in the GitHub repo, so I posted that on the meetup, and then
Excellent.
shared the threads. So check the meetup, and that has all the information you need.
Perfect. So take it away. It's all you. You are the co-host. So if there's anything that I have to step away for, you are in full control. And here we go.
Awesome. Thank you. Thank you. Yeah. So this is the everyone. My name is Ivan Bliskavka. I'll kind of do my introductions here, but I'll kind of start here. This is the repo, and so check it out. But here's my presentation link. So you have everything that we're going to cover today. So I'm going to jump right into that. So, right, this is my first FloridaJS presentation, and this is probably the most people I've ever had listening to me at the same time, for better or for worse. And hopefully it won't be my last. But today I want to cover the basics of running a serverless web stack in the AWS cloud using serverless technologies, right? And more importantly, repeatable deploys. So first of all, my name is Ivan. Whenever I was a kid, I wanted to be an inventor like Edison, like Tesla. Then I discovered video games and burned way too much time there. But eventually I discovered software engineering. And to me, software engineering is an invention. Every day you're solving some new thing. So I think 10-year-old me would be proud. My day job is I'm a team lead at Voice Foundry, and we integrate cloud-based call centers on Amazon Connect. And just FYI, I am not representing Voice Foundry here today, but I will plug them anyway because I'm really proud of what we've done over the years. And Voice Foundry is a consultancy, and we kind of basically every few months have to rinse and repeat same kind of things. So we've developed a lot of patterns around serverless technologies into AWS, and I'm going to share some of the basics with you. None of it is secret sauce, but I think you will find this useful. Before we jump into the architecture and the presentation, I just want to make something clear. Effort is not work. So if you carry a piano up the stairs, it is the same amount of work as using an elevator, right? But it's tremendously more effort. So if you're running virtual machines and you need to keep them in sync and patched, if you're running physical servers, you need somebody on call because a disk might fail at 3 a.m. on a Saturday night, right? And when referring to services provided by AWS, Werner Vogels coined the term undifferentiated heavy lifting. So in this case, undifferentiated means it has no effect on what makes your app special. So what I'm trying to say is what makes your app special is work, and everything else is simply effort. So serverless allows us to, technologies lets us offload the heavy lifting onto our service provider, right? And then we could focus on what makes our app special, and we could focus on the work. And on a side note, like, I believe the most dangerous part of the applications I write is my code. So if I can lean on proven open source libraries or managed services, that reduces risk. And what is serverless? So first of all, it's a buzzword. It's used everywhere, especially on marketing materials, and it means different things to different people. But for the sake of this conversation, serverless means using on-demand auto-scaling managed services rather than paying for uptime, rather than running VMs. Or not necessarily VMs, even like managed services like RDS, that's a per hour charge. So to me, it means that I pay for what I use, and there is no minimum charges, and it scales in case my app goes viral. So in reality, most applications won't be purely serverless, but it's a great goal to have. And if you're bootstrapping your startup or bootstrapping your app, you want to not have to pay a bunch up front. And if it goes viral, you want it to scale automatically. So let's take a look at the application stack today. So I kind of modeled this demo on a 3-tier application, like a classic presentation tier, application tier, data tier. So in this case, our presentation tier is our React application. Our application tier is this Express app all the way over here. And our data tier is Dynamo DB, which is the AWS NoSQL database, and S3, which can be used for files, right? Everything in between is effort for the purposes of this demonstration. So let's start up at the top. Amazon Cognito is the AWS identity service. It has a lot of different features, including MFA. It can federate with social identity providers. It can federate with enterprise identity providers. And it has like hosted UIs and all sorts of things that are available. And you'll see how quickly it is to set up with a template. And I wouldn't trust myself to write my own identity provider, so never do that. Amazon Route53 is the AWS DNS service. We won't really spend any time here because everyone has a different DNS. And AWS Certificate Manager provides free auto-renewing SSL certificates when used with AWS managed services. So if you had to install, if you had to buy a $300 certificate and then put it in your Nginx build for terminating the SSL, and then you forget to renew and forget to update, and all of a sudden your site has the big red bang because you forgot to update your cert, well, this takes care of that. You don't have to worry about that situation. Amazon CloudFront is a CDN, so you can think of it as a proxy. This terminates our SSL, and all interactions happen at this kind of at this CloudFront URL. But the backend, CloudFront, has multiple origins. So for example, we are serving up our React assets from a S3 bucket on the default route. And the API is being served up on the /API/start origin, right? And that is actually pointed to API gateway. API gateway is essentially a managed service that manages your REST and WebSocket APIs. So it manages the connections, and it provides a lot like additional functionality. For example, AWS Shield will give you some DDoS protection out of the box. Additionally, API gateway can be configured to automatically authorize the JWT token that was generated by Cognito. So before the API gateway even hands off the request to your Express app, it has validated that this user token is correct. And then API gateway essentially does all that work and hands off the event to Lambda. For those unfamiliar with Lambda, Lambda is a function as a service, meaning it's compute that you pay for invocation and execution time. It is charged by the millisecond, which for fast running applications can be really cheap. And for the sake of today's conversation, we're using Express, but Lambda can actually interact with the raw events and send raw events back and forth. I like the Express like local development experience, so I use that in today's demo. So before we move on to the next slide, there's one more thing that's off to the side here. It's not really part of my application per se, but it helps the deploy process. Our orchestrator here is CloudFormation. CloudFormation is the infrastructure as code service provided by AWS. You give it a declarative layout of all the resources that you need, and it creates a change set, and it deploys them, or it removes stuff, or it updates things. So that's what CloudFormation does. And it can also execute arbitrary code, which can be basically packed into a Lambda. So what we're doing here is extracting a zip file into the bucket and basically configuring the React application. So we'll see that here in a sec. So code and infrastructure is great, but just as important is the deployment process. So we talked about CloudFormation a little bit, but the reason why I stress this is the biggest risk of a deploy is user error. I've been in companies where you literally have to write a Word document with click here, click that, click another thing, and then a rollback plan in case something fails. So with CloudFormation, with SAM, you don't have to do that. We are, as a developer on our day-to-day operations, you're actually executing directly from your workstation. You do a build, your CLI logs into AWS, your SAM deploy creates a package, puts it in S3, and then executes CloudFormation. So we'll see what that looks like here in a sec, but it's literally just, deploy.sh at the end of the day. There's a little bit more that goes into it, but it's fairly seamless. So that's the developer experience. But in my experience, operations people do not want you to deploy code into production. Also, clients don't want you to deploy your code into their account. They want to do it. But if you have a really sophisticated build chain on your machine, it's quite a chore to get that configured on the client account or on the operations person's computer, right, on their laptop to execute. So the way we do it with SAM is you're actually doing the packaging step as before, but it doesn't execute the deploy. It puts the template into the artifacts bucket, and then you hand off the S3 URL to the client admin or to the operations person. And then they could deploy that into account, and your bucket policy can allow other AWS accounts access to your bucket. So think clients, think QA, think prod, all of those AWS accounts that are, as a developer, you may not necessarily have access to. So let me show you what this step looks like real quick. So I already built this, so I'm gonna copy this. So this is just the result of running package.sh. It's actually included in the code, and then it spits out this S3 path. Wrong one. So this is what a deploy looks like. I go over to CloudFormation, and let me move this over. I create a new stack with new resources. My template is ready. I have the S3 URL right here, so I'm gonna paste that in. I hit next. Now I can name the stack. A stack in CloudFormation is all of the resources that are created together, and when you delete the stack, all the resources gets removed. So it's a specific installation of your code plus all the related resources. I can have multiple parameters and optional parameters I have this ACM cert ARN and then app alias. I made these optional. I'm not going to demonstrate them, but like if you were going to set up SSL with a custom domain, you would use those. I'm going to do my admin. So there you go, 3 parameters, and then I hit next. Basically next, 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 the usual terms and services, business, and that's it. My application is running. So in here, I could actually see the events as resources are being created. And we'll come back to this in a moment, but let me circle back to the presentation because this is going to take about 5 minutes to run. I want to bring to your attention another deployment strategy, and that is available with SAM. So this is the serverless application repository. The serverless application repository is essentially an application catalog. It's not a marketplace because there is no way to charge someone for your work, right? But you can share your applications with your account or with other accounts, like privately. So think, other accounts in your organization, or think client accounts. And basically the process is very much the same. It runs the packaging step, and then it publishes the metadata to the serverless app repository. And then the client, after you share it, the client or the ops person goes to the serverless app repository and then deploys it from there. And then CloudFormation takes it from there, same as before. So we're going to look at the code and just go through the demo a little bit. Shameless plug here, by the way, Voice Foundry is hiring AWS engineers. So if you know your AWS and you know Node.js, send me some info. So when I come back to this stack here and refresh, this window is bothering me. So you can see here that we've been able to hear all the resources that are being created. And this app distribution step takes a little while. So while that's running, let me show you what happened in the background. So I received an email. So here is my app temporary password, username, temporary password. This was created automatically, and you could customize this email. I didn't bother for this presentation. And let me also point out that while that's running, let's take a look at Cognito. So Cognito is the user management FLJS demo. So this was created for us. Here's the user that was created for us. Here are the groups. Well, group. But this is it's not like an IDP, but it's a, anyway, it's a user management system. And you could add additional claims, and you can configure MFA, and you could give users like advanced security policies and federate with additional, external providers for enterprise and so on. Additionally, you could configure like the hosted, the UI customization, and there's like a bunch of stuff in here. But it's really powerful if you if you want to get started quickly and you don't want to spend a bunch of money. It's not as sophisticated as some other systems, but having everything roll up in one bill is pretty nice. So while that's running, can I answer any questions about what I've talked about so far? Oh, perfect. So the CDN, the distribution, does take a minute. Let me just, oh wait, hold on, it just completed. So it's going to do the final steps. We'll wait a minute. I was about to switch gears and look at something else. There it is. So you can see that it created the CDN, and it's now about to install the front-end assets. It's deploying the front end. Okay, it's ready. So if I look at the stack outputs, so stack, you have parameters, you have outputs, here's all the resources that were created, and of course the events. If I look at the outputs, you can see here's my app URL. Here is the data bucket that was created that we can use, and here is the data table that was created. So let me open that up. This is using the hosted UI for logging in. But you can, there's actually a React component that you can drop into your application so that you can have your forgot password, your sign up, your login, log out, all that other business themed and part of your application. But for simplicity, this is just using the hosted UI. So this is the little demo app that I put together. It is trivial. It's literally does no validation, but I feel like the point of this exercise was to show you how everything interconnects and how everything deploys, rather than build a fully functional application. So you can see I added a new contact. I refresh the page. It's still here. If I go over to my table, here is the table that was created, the NoSQL table. So if I look at the items, here's the record that I just added. So very simple to deploy once everything is wired up. So if we're building like, I find in enterprise, a lot of times when we work with client, people want a SaaS, but they want to run it in their own AWS account. They don't want you nosing around their data, right? So this becomes like very easy to give somebody a link, share the bucket, give somebody a link, and then install it. So that was the deployment experience. I'm about to switch some gears and show you what the developer experience looks like at the end. And this is a good time to interrupt if you have any questions. Sound good? Excellent. Sounds good. So the reason why I chose to use an Express application, because it can be kind of a chore to debug your application, basically your application when it's running in Lambda. SAM will allow you to essentially, like, we will pull down a Docker container that is the Lambda runtime environment, and it will allow you to run it locally. But it's really not as fluid as what you're used to if you're used to like the mean or MERN stack with Express. So because of that, I actually set this up in Express. I don't actually use Express day to day, but for an application that has like a lot of endpoints, you might consider it. So this project, the backend, it actually has a launch configuration to run the debugger locally. So I'm just going to go over here and hit Debug Express. This is going to start the Express server locally on 5000. And then on the front end side, so let me point out one thing here. I have a breakpoint right here. So if I, by the way, this is, I mean, should be obvious, but this is all TypeScript. Sometimes it can be a real chore to get those debuggers to work correctly with TypeScript. There's a lot of hard-fought hours to get this right. So if I put a breakpoint here, whenever I'm adding a contact, and let's go back to the application. So this is now running locally. Wow, there's so much UI overlays. Hold on a sec. Let's do this. Yeah, that's correct. That's correct. 5,000 is my API port, and 3,000 is my React scripts port. So I'm running the React application. So in here now, if I add, I'm already in here, but let's add it again. I hit submit. You can see on the left side, the debugger is attached to my Express application. And I could inspect exactly what I am writing to the Dynamo table right here. So there's the table name, and there's the model or the record that is being written. So there's my partition key, my sort key, my email, et cetera. And hit next, and it continues on. Reloaded, and let's see, I'm using the email as the partition key, so it simply updated that record. But I wanted to point out the debugger and the breakpoints on this side before I kind of jump into the configuration. The other thing to call out, like if you look at the repo, I put this in the READMEs, but there's a config file in the root. And this is essentially, this is telling me where to connect to, right? So this is localhost 5000 in production, or once it's deployed to the AWS, it'll be obviously a different URL or just going to be the same URL, right? But that is basically the UI. It's very simple. I didn't try to get too flashy there because everybody has their own code development process. But I think that this will translate well to Angular or Vue or anything like that, because at the end of the day, you have a single page application using Fetch to talk to your Dynamo, to your Express application. Let's see.
Evan, a quick question, if I may.
Sure.
On the AWS side, where do we run Express app? Do we have EC2 instance, or is it a container? How do we run that?
Glad you asked.
Express app on AWS.
Great question, because it is a little bit, it's a little bit wonky, because there is no EC2 instance. There is no EC2 instance. It's actually running in Lambda. So when you're running locally, it's actually the launch config kicks off this server.ts. So this is the local server. I got lazy, so I hard coded my environment variables here, right? So see that process env, blah, 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 all that stuff is in here. And then I'm launching the server here. But when my code is executing in AWS, this is the entry point right here. So lambda index.ts. And so this is the application entry point. And you can see that API gateway expects a function. So this is, we're actually like calling a function. We're passing in the event, and we're passing in the Lambda context. And here we're creating a server. I think that probably in hindsight, this server needs to live outside this function so that it will survive multiple requests. I think right now you know what? I'll just move it. Okay, perfect. me see. What did I mess up? Oh, right.
API is the same name.
There we go. All right. See, never make changes during a live demo. It's just not worth it. So, so essentially, when on the first time the Lambda executes, right? This index file will run, and it sets up all of these objects, and then the actual event gets passed to the Lambda, and then the Lambda calls this proxy thing. Basically, there is a project out there created by AWS called AWS Serverless Express. It's basically, from what I understand, is it translates the API gateway event into something that Express can understand. And the way this works is Lambda runs for about 15 minutes. It's a container, and then it automatically recycles. So the first time you run, there's a cold start, and maybe it's half a second, maybe it's a second, and it configures all this business. And then that container is around for 15 minutes, and any new requests get forwarded to this function, right, which gets forwarded to your server. And so from after the cold start, it's really fast. And as you know, Node.js is single-threaded, so it can only handle one express at a time. But if you have a spike, AWS accounts have a default soft limit of 1,000 provisioned Lambdas, like concurrent Lambdas. So if you have a spike because your app goes viral or whatever, it doesn't matter, Lambda will automatically spin up additional containers. So if all of a sudden you have 1,000 users, the system will automatically orchestrate and spin up resources and automatically scale. But yeah, there is no EC2 instance running Express. It's all functional here. So let me talk a little bit about the configuration and how all this stuff is lined up. SAM and CloudFormation really uses this YAML syntax, and SAM is and I'm sorry, I keep using SAM. SAM means serverless application model. So it's the kind of like the default packaging system for serverless application from AWS. So it will, compile your code, build your code, zip it up, upload it, and then deploy your assets, your resources, right? So I'm going to quickly jump through this this template because it's probably a lot if you've never seen it before. But I added this stub here in case you want to try deploying it to the serverless application repository. It requires this additional metadata, and that's what's used to update that catalog. And if you remember from the deploy, here are our parameters. We can configure globals. So Lambdas are containers, right? So the way you inject configuration into them is through environment variables. So that's what's going on here. And additionally, it supports conditionals. Like I mentioned earlier that the ACM certificate is optional. These conditionals allow you to add and remove resources depending on which parameters were passed in. Here is the data table that we created. I'm using pay-per-request billing. So if you don't know what kind of volume you're going to get, or if you have like really low volume, pay-per-request is a good place to start. And then once you've seen what your standard throughput is, then you can do provision billing, and there's there's cost savings there. So here's our bucket, here's our user pool. So this is the Cognito stuff we looked at earlier. So you can see that, here's I'm customizing the email message. So you could inject some additional information here. Here's a user group, here's the admin user, here's the group membership, basically this kind of declarative syntax. And I'm gonna skip this Cognito stuff for a bit because it's kind of a lot. But we're getting to the REST app API, so you can configure cores. Configuring cores on your API is as simple as this. The way I have it here is if it's in production, I don't allow cores. Otherwise, I'll allow cores from other origins. So like, local development or dev, that kind of stuff. And here's the default authorizer that I showed you earlier. Well, mentioned earlier. This will automatically expect all users to be authenticated by this user pool. So you could have custom authorizers, but this is an out-of-the-box thing that says, hey, everyone has to be authenticated. This is the actual API function. So you could see here, it's pointing to that code handler, right? So SRC Lambda Index API. And what I want to point out here is you can split out your API, your Lambdas, and you could do granular permissions. So for example, if you have an API that is maybe accessed by unauthorized users, then you might want to put in a different Lambda function for the purpose of, if there is a code error, then that execution cannot access certain assets, right? Or rather, it only has the limited permission set that it needs. And then, of course, here are all the events. So here's my bindings. So API contact ID, API. Like you can use a proxy. You could do like a wildcard and just forward everything to Express. But if you've ever managed a server, you'll see that there's a lot of robot hits for like, a WordPress admin and stuff like that. You don't actually want to forward every single request to your Express application, because then you're incurring charges for like crawlers or things that are simply trying to see whether you have WordPress installed. So this essentially says, I'm expecting these routes. Anything else gets a 404. So this is the custom resource function that I mentioned earlier, and you could dig into what exactly it does in this custom resource folder. But essentially, you see here is I'm giving it permissions to add and remove files, CRUD operations on the application bucket. Additionally, I'm giving it permission to create an invalidation on the CloudFront distribution, which is, of course, the CDN. So that's the function definition, and this is the actual deployment step. So this is saying I want to execute this custom, this custom resource function with these parameters, and all it's saying is, hey, I'm looking for app.zip, which is packed into the build, and here's my destination, and here's my app distribution for creating that validation. Additionally, I want you to write this data into the config file. So you can see that it's taken the region, the API URL, the Cognito information. This is what allowed us to simply run the CloudFront deploy, and the React application knew exactly to which Cognito to authenticate with, right? And then last but not least, here's the actual hosting of the React application. So there's a bucket, there's some origin, there's some policies that only allow access through CloudFront. And this thing is a little bit, I get that there's a lot here, I just want you to be aware of it. Here are my origins. So on one origin, I have the application bucket, right? And then the other origin is the REST API that we created. So this allows us to use the same domain for both the React application and for the API gateway. And then additionally, there's some cache behaviors that you might configure for, like, for example, API/star. You don't want to cache anything on your API, right? Whereas you probably want to cache your React application. So there's a bunch of edge locations in CloudFront. So the closer it is to the user, the faster it loads. But since we're putting CloudFront in everything, we want to make sure that we turn off caching. Additionally, if you're sending large JSON blobs, those things get pretty big. So you could have CloudFront automatically compress this for you. And here are the outputs. So that is configuring that stack declarative in CloudFormation in a nutshell. I'm going to kind of pivot to the front end just a little bit to call out Amplify. Amplify is essentially a library that will interface. It basically allows you to more easily interface with AWS from like a single page application. You know, if you're running server-side rendering, you probably don't have to worry about it. You just call the SDK directly. But you know, on the client side, it's low trust. So I mentioned that there's this config file, and basically this allows you to configure the application like at runtime. And there is a, yeah, don't judge me on my React. I just learned React recently. But we've been using this pattern for like Angular and a few other things. So when you are, essentially, there's some configuration that needs to happen before you can start you know, using Amplify and so on. So you can see that I'm loading the config.json file, and then there's basically this configuration step, which you could hard code into your React app, and it'll work just fine. But my recommendation is to use that JSON file because it makes your distribution portable. And this is just an example of how to configure it. And then later, you can actually pull out the JWT token from the session. And Amplify will automatically, it's a 1 hour access token or ID token, and it will automatically negotiate the refresh. Because if you ever had to deal with, anyway, with this kind of stuff, there's a refresh token, ID token, and access token. It handles the refresh implementation. So you get the user information this way. And later, when you're actually interacting with your API, I like to use these, if anybody's on .NET, this might be familiar. That's kind of where I got my start. There's a shared API interfaces. This thing gets copied in from the API just so that my interfaces and my objects and my schemas always match up. But later, whenever you're actually doing a call, you can see here that we're building the authorization header. This is just the request, get token, get JWT token. And then we're interacting with, API URL endpoint, and then all this, you're familiar with JS, then this stuff should be fairly familiar, but I just wanted to call out that Amplify makes this a lot easier for you. So I think that is basically everything I wanted to show today. So any additional questions or comments? I'd be happy to field them for you.
I have a question. Hi, Evan. I'm Xavier. Thank you for your talk. I actually just used Amplify in a week-long project in the bootcamp that I'm going through right now. And I also happen to have an AWS certification, so I'm kind of familiar a little bit with AWS. I didn't really use SAM all that much, and seeing it here compared to just straight up CloudFormation, it seems to be very human readable. And I was actually like on the edge between, using, looking into SAM versus looking into something else like Terraform. Would you say you prefer SAM over Terraform or other declarative formats?
Yeah, so I could comment on that. So Terraform is kind of a multi-cloud infrastructure as code, similar to what you saw in CloudFormation, but it works with GCP and Azure and a few others. So if you are like a consultancy that touches a lot of those things, Terraform is definitely the way to go, but at the end of the day, maybe the syntax is the same, but all the resources are configured differently. So you can't, if you're looking for a portable stack, you can't just pick it up from Azure and put it in GCP and put it in AWS. You still have to rewrite everything, but your syntax will be similar. It rather will be the same. So you don't have to like learn yet another syntax. So like for me, because we are a AWS advanced partner and we do AWS all day long, this is the lowest common denominator for our customers. And like some of the other things that we're looking at strongly is like CDK. But for me, the reason why I kind of prefer SAM is because it's a build once, deploy multiple times model. Whereas with like serverless framework, which is another competitor, or CDK, is you have to recompile it every time you deploy it. So whenever you're like have a long running, multi-year application or an enterprise application that you're maintaining, that's really great. But since we tend to make things that we want to, install on a customer account and just send them a bill, SAM works really well for that.
Thank you. I'll leave that one up to you. I don't have all that much experience.
Well, there's something like 600 services in AWS. So yeah, you can't really tell, what's lumberyard, right? So first of all, you need to figure out what your domain is. And if you, and here's the thing, like if you want to get certified, then follow a certification program. They're well defined. And like if you're a generalist, I recommend the serverless, rather the solution architect. There's practitioner, then there's solution architect associate. And I recently got my pro cert, but that gives you a feel for the entire ecosystem. So as a developer, you might not actually want to do all that because you're not really kind of planning the forest, right? You're working on your trees or your little grove, right? So, but to just get started, I think the simplest thing is to like go to SAM, go to the SAM CLI website and pull it down, and then write some basic Lambda code. And really, the starter code, the hello world code, is actually really great. And you could put it up there. And for example, a Lambda that pulls some resource every hour and then sends an email is like a trivial thing to do. And that's a good way to, like, from a developer perspective, or something like serverless framework makes it stupid easy to deploy. But learning, man, you got to learn by doing. And there's so many different features. I would say look at those associate certs.
If I can piggyback on top of that real quick, I got my certification just through studying AWS from a Udemy course actually, and I didn't end up writing as many applications or projects as I should have throughout that course. So I definitely recommend getting your hands dirty and actually putting what you learn into practice. You'll learn a lot quicker building sample applications and putting your learning skills to test, much more so than just watching some lectures on that. Because yes, it did allow me to pass my developer certificate, but at the end of the day, now I kind of forgot everything, and I'm having to go back and get up to speed with that.
Yeah. So yeah, certainly. Let's take a look at that real quick. So these are I put the deploy files in the root. And let's kind of jump through that real quick because there's a couple of important things. First of all, build.sh doesn't require any permissions. It runs the build for the backend, and then it runs the build from the front end. But I kind of glossed over this earlier. Take a look at this. This is actually zipping up and copying the front end build into this folder, custom resource function app.zip. So this is bundling it into the Lambda, and this is what allows CloudFormation to deploy it later. So that's one. The other thing that you need to get started is, let's see, deploy.sh is expecting environment variables. And the reason why I did this is sometimes this is executed from like a code pipeline or like GitHub Actions or anything like that. So the file you care about is this deploy.dev. And this requires AWS CLI. So I put some prerequisites, but I didn't really link them out. You need AWS CLI installed, and you need your profile installed. So right now, this is default. And whenever you configure AWS CLI, it's going to ask for your secret key and access key. And then that puts it in the profile. But like if you're running multiple deploy different accounts, you'll have different profile names. There's that. And the other thing that you are going to want to change is this bucket. As I mentioned before, the artifact bucket is where things get staged. And this needs to be created beforehand. So I kind of follow this format, but this can be called whatever you want. So. No, this could be any email. Frankly, it can be blank. And you know what? I'll just leave it blank for this code. But you know, this is whenever you're deploying, this is going to create your first Cognito user, right? So whenever you set this, this is going to create the user account, and it's going to send the invite email to this account. Yeah. Yeah. As a side note, if you're developing bootstrapping like a small project, I have an app that I've been running since 2015, and I used to have Azure credits. So I had a really tiny VM that was running in Azure. It still ended up being like $100-something a month, but when I converted it to serverless, because it's only executing essentially, once every hour to update and refresh the data, and the data is being served up from S3, my bucket quite literally, my bill quite literally went from over $100 a month to like 75 cents because of my Lambda execution. And like, I think the biggest part of like, then you have to charge, you pay for like the hosted zone in Route 53 and whatever, but my actual execution went down to less than $1 from 100.